Your phones are put away, okay? So here we go. We will talk about this. We're going to talk about this first example here. Okay. So the height of males in Canada is found to be normally distributed. The mean height is 177 centimeters. The standard deviation is 2.5 centimeters. Graph a normal curve indicating the percentages within plus or minus 3 standard deviations. That's very standard, okay? Include z-scores as well. Is it possible that you can have more than 3 standard deviations? Yes, but it's so negligible that we usually don't include it, okay? There's so few data points there that we don't include it. So when I ask you to do it, I may give you something like this, but if I don't, you just have to make a straight line here. And we start with the average, which is 177. Okay? You put the 177 right in the middle. Call this the height. And what are we measuring height in? Centimeters. So just put height in centimeters and just put the values in here. And we're going up by 2.5% in this case. So 179.5 would be this. Okay, and then we have just 182, and the next one will be 184.5. So what did we do here every single time? We added a standard deviation to it. We added the standard deviation every time. And so if you want to go to the left, obviously you subtract a standard deviation every time. So this would be 174.5. Make sure you write this down. Minus 2.5. This would be 172. And this is 169.5. Okay, so that's how you don't have to show me these arrows in the future. You just put down the numbers, okay? I'm just going to assume you know what you're doing there. It's asking you for the z-scores as well. Z-score. So what I need you to do is just right underneath, just go z-score like that. I like them both on the same because it's like they are related, right? So z-score at the middle would be 0. And then this would be 1, 2, 3. Negative 1, negative 2, negative 3. So a height, if a male has a height of 179.5, that has a z-score of 1. We know that for sure because it's on our graph. And it's positive 1, which means that this height puts you above the mean. And specifically 1 standard deviation above. Fill in the percentages. I'm just going to quickly do this here. 34. And don't be lazy about this one. Sometimes you don't do the percentage or whatever. Make sure percentages are there. Okay, 13.5%, 2.35. If you need an arrow to make indicate where the percentage goes, that's fine. I use the same thing going to the right. 0.15%. These ones up here, you don't have to have them every single time, but I will just indicate that it should be 68, it should be 95, and it should be 99.7. But the whole curve is 100%. Okay? But going 3 either way, 3 standard deviations either way is 99.7. Okay? And now we can answer a bunch of questions based on this. Okay? So let's see here. Once you fill this in, answer the following using the graph. Okay? Using the graph. What percentage of males are between 172 centimeters and 179.5 centimeters? Where would you start? The 172 is right here. Just make sure you look up, right? 172 starts at this line right here. And we're going to add up the percentages until we get to 179.5. which is right here. This is where it ends. So we're going to add 13.5% plus 34 plus 34. And what does that add up to? That one is 81.5%. This is for Canada. It would be different for a different country, right? So Canada follows this normal distribution. However, or, okay, write down or here. There's another way of answering this. I'm going to make a line here if you can split this. This is probably what most students will gravitate towards. This is direct reasoning. Indirect is this. What is the area, what's the probability under the entire curve? Percentage-wise is 100%, correct? What am I going to subtract from 100? Which ones do I not want to be part of it? Just look up here 1 second. We just care about 172 to 179.5, right? We just care about that. So guess what I'm going to do now? I'm going to cover up this. What am I going to subtract from 100% to be left with this part? I'm going to subtract these chunks right here from 100%, and that's going to leave me with that 81.5. Okay, so let's go ahead and do that. I want you to show that this piece, otherwise you're not going to know what happened here. So I'm subtracting these two, and I'm also going to subtract these three at the end here. Okay, minus 13.5, minus 2.35, minus 0.15. That should be 81.5. If not, we're in trouble here, right? So regardless of how you approach it, you will get 81.5% of males. Okay? I wonder if I should, just for this particular example, highlight. I'm going to go for it. I'm just going to go. I'm going to say that these three numbers amount to 81.5%, and so that is this area right here. Okay, that chunk is what I want. And what are these things that I subtracted here? I'm going to use a different color for that. Those would be, right, these areas that are on the tails, right? I subtracted this tail, and I also subtracted that tail from it. Okay, so that's how I came up with the 81.5%. I don't need you to do both methods every single time. Whatever works for you, okay? C. What percentage of males are expected to be, sorry, that is something went wrong there, typo, right? Are expected to be taller than 182%. Sorry, centimeters. Where's 182? It's right here, correct? If I asked you for taller, which side would you add up from 182? Would you add up the left side or the right side? Right side, yeah? Taller. This is taller. So you just go 2.35% plus 0.15. So it's 2.5% of males. So what I'm saying here is that the chances somebody is taller than 182 centimeters in Canada, based on this stats, and I got it online. This is actually based on Stats Canada, right? 2.5% of males will be taller than 182 centimeters. So not a whole lot, right? What about this? What percentage of males are shorter than 169.5 or taller than 179.5? Okay, or folks means you got to add it. Okay, yeah. So what's what I'm going to do here? I'm going to figure out shorter first. Shorter 169.5 centimeters. Let's figure that out. And then I'm going to figure out taller than 179.5. And let's get those percentages. Let me zoom in for that. Some of you are having a hard time seeing, I'm sure. Let me also focus. There we go. So shorter than where's 169.5 is right here, correct? What percentage is shorter? 0.15. That's it. You're done there. Taller than 179.5. That's right here. This will be 79.5 is right there. So taller is all of that. So that's 13.5 plus 2.35 plus 0.15. That adds up to 16%, correct? And here's I'm going to give you a heads up for next year. Or in math, you got to add. If it says percentage shorter than this or taller than that, it means you need to add those two percentages. So I'm going to add this up. Okay, that would be 16.15% if you add both of those up in total. So today, just follow me. I'm not going to give you time in class to do this. I just want you to follow along because there's a lot of different questions that I have based on this one right here. And so homework is going to be on you there to do this again. Okay. Keep this graph on there. Like, I mean, it's right next door, so just make sure we're going to come back to this every time. What does it say in E here? What is the range of heights for 99.7% of males? Let's answer that one first. Does 99.7% ring a bell? Have you heard of that number before? 99.7, how many standard deviations apart are they, you think? 6. There's 6 standard deviations apart. So basically, this represents, right, the range from here, -3 standard deviations, all the way to here, where it's +3 standard deviations. Okay. What is the number right underneath the third standard deviations, or going 3 standard deviations to the left? What's that height there? 169.5. And we can just do dash. Dash. What is the number under 3 standard deviations plus? 184.5 centimeters, correct? So the range of heights for 99.7% of males is between 169.5 to 184.5. That's what it is. Okay. Guess what it's going to be for 95? How many standard deviations are we talking? How many? 4. -2 standard deviations, +2 standard deviations, right? So you go grab that number. This would be 172. And then we go dash. The other one is 182, correct? So 95% of males, the range of heights is this. How did I know this? Because 95 told me there's 4 standard deviations in between. Okay, 68, how many standard deviations there? 2, right? 1 standard deviation to the left, 1 standard deviation to the right. We have 174.5 all the way to, what's the other one? 179.5. Okay? That's how you do a question like this. You know what? I forgot you say of males. Of males. I could have asked you any one of these, okay? I did all three just to kind of walk you through the process. Question, is it always going to be the height of males? No, it's going to be the volume in the can of pop. It's going to be number of days studied for a test. Like I could ask you all, like how many days did you study for the test? No, I didn't study a single day, 1 day, 2 days, 3, or hours. Maybe we should do hours, right? So normal distribution is all over the place, okay? What about the next one here? I would expect you to know how to do this one right here. Maybe you know, maybe you don't. If Canada has a male population of 17 million, right? So if every 3 zeros put a comma, then you can determine the number of males that are shorter than 172 centimeters. It's not asking for percentage. It's asking for the number of males. You need to actually figure out the number of males. Number of data. You go percentage divided by 100 times total. Okay, that's the formula kind of that you want to maybe write down on your study sheet. So how many percentage-wise, how many are shorter than 172 centimeters? Let's do this first. 0.15 plus 2.35. I add up everything to the left of 172 on my graph. That's 2.5%. Can I write this down here? You should do that too. Likelihood. It's the same thing as probability. If I throw the word likelihood, it's the same thing. The chance. Okay. So males, right? How many are we talking about? 2.5 divided by 100. You multiply that by 17 million. I don't expect you to write this every time, folks. You can just do this on your calculator right away. It's 0.025 times 17 million. And when you do the math, you get a round number, 425,000 males are expected to be shorter than 172. Sorry, did I made a mistake, right? No, I got it right. I got it right. I just thought I added the wrong side of that number, so that would have been a problem. I think the rest, I'm going to leave them up to you. I need you to try. I know it's going to be scratch. You're going to scratch your head on some of those. And 27 to 28. You know what? I'm going to allow you to, for now, just go straight to 27 to 28. Leave these ones for tomorrow. I would encourage you to try them, okay? But 27 to 28 doesn't have as many layered questions, okay? It's asking you to make a normal distribution curve. Before you pack, let's go to 27. I'll get you started. Packing, you guys are really quick at it, eh? You'd be ready to leave in a heartbeat if I had to evacuate this classroom. Okay. Volume of pop cans are normally distributed for large samples. The mean is 355, standard deviation is 2.75. Watch this. Graph a normal distribution curve, plus or minus 3 standard deviations, yada, yada, yada. You grab a ruler. I'm going to get you started, so you're welcome. You draw a line. Make sure it's a nice and spread out. Okay, if I give you that much space, then using your ruler, make a line. This is your middle. And then use a consistent scale, and you go up 3 to the right. So this will be 1, 2, 3, and then you go to the left and do the same. 1, I do every second centimeter. Right? That's my line. So what's going to go in the middle, folks? 355, right? And how are you going to come up with these numbers? You're going to add standard deviations and you're going to subtract standard deviations to come up with these numbers. What should go along your axes here? This should be volume in what? Milliliters. So the next one, you're completely on your own. You go to the mean. Go all the way to the top. Make sure you don't just go this high, right? Because you're not comparing it to another data set. Just go to as high as you can. Make a dot there. And then just curve it down. Never touching, of course. And then you do the same thing on the other side. Okay? What else? What else do I need to do with this one? Slice it up. Slice it up. So you kind of do this. And no sloppy graphs, okay? I mean, these are your notes. I won't find out, but on AC, has to look decent, okay? And what are you going to fill in here? Percentages, right? This, to be honest, I noticed that my scale is off. So, and then answer the questions that follow, okay? Thank you guys. 27, 28 for tomorrow.